Welcome to the channel where all you got to do is get this into CAD. So basically what we have here is a 3D scan of the 68 coupe that I started this project out with. And you can see there's some detail in here of the sills and the firewall area and underneath. Let's rotate this over. And what I tried to do was um, make this into a step file and then import it into CAD program, which I happen to use SolidWorks 2012 because that's what I own. It's a little bit old, but it still works, so I'm not going to pay for a new one or provide, most of the new ones are subscription services, which I'm not a big fan of. So as you can see, there's pretty good detail on the bottom here. But when I tried to import the step file, it was just too big. SolidWorks just crashed. However, I can take this this file from my 3D scanner and put it into FreeCAD. And then in FreeCAD, I can get it aligned up and put the center point where I want it and line up the axes where I want it. And then if I import that into SolidWorks, it's fine. It's a little bit slow, but it's fine. And then I save that underside as a assembly. So I have an underside aligned. This is my second version of aligning it. So, and that's fixed in space. And the problem that I had with the 3D scan STL file import is you can't move it. Like once it's in there, it's in there. It's just fixed. No matter what you do, you can't move it. So I just made it into a solid assembly file, and then I import assemblies into that. So, and then I can move the frame assembly file relative to this and get it where it lines up. And as you can see, this scan, these purple things are the frame rails. And then I have this frame assembly. Pop that open, which is that. And then this is easy to work with, right? Everything's light. Like these are just crude approximations of, whatever. And I can manipulate these around. The zero's in the same spot. And I could be, so basically what I'm using the 3D scan for is to visually look for clearance issues in 3D space and also position these frame rails, right? This is what the frame rail looks like in the car. And if I go to the underside assembly, I can see that, it's got some little areas of sticking up, little areas of sticking down, but in general, it's where it is, right? Within the build quality of a 68 Mustang. So now when I get my turbos placed here and the exhaust and all that stuff, transmission, linkage, blah, 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 I can check clearance to all this stuff and know what I'm going to have to modify before I get out to the shop. Frame mount, suspension, motor mounts, all that stuff, radiator mount. All that stuff I can do in 3D space. And this one's like the first scan I did. So it's not terrible, but I'll be doing more. Right? It's on a rotisserie. Once I get all the fastback pieces on there, and aligned, well, they're in there now, but they're not super aligned. So I got to get the hood put on and the fenders put on and the doors hung with the new hinges, and then I can make sure the fenders are all lined up. And so that's how I'm using this tool. It isn't what I intended to do. I intended to put a step file in here, but it's just too big, right? So, and maybe I'll scan this. Like you can see the quality of this scan is pretty darn good. Like it probably doesn't need to be that good. But this is the wheel tire, not the design of the wheel, but the size of the wheel. This is the package that I'm running. These are 315, 3018s all the way around. So that's where I'm at on this. Yeah, the only problem with it is it's really slow. You zoom in and it takes, 2 or 3 seconds to. You can see a little bit more detail here. These are the brakes I'm planning on using on the rear. These are the frame connectors. You can also see I scanned the underside pretty well over here, and you can tell this tire is even without any motion, it's already running into the inner fender well. So I'm going to widen it quite a bit so that goes away. But yeah, that's what I'm using this for. There's also going to be some fuel cells sitting in here. There's probably going to have to be a little modification right here and right here. Um, so yeah, that's where we're at. Welcome back. So done a little bit of CAD work since signing off. It's been really cold and rainy here, so um, trying to get any work done on the bus is challenging because it's in the garage, but in order to work on it, you got to open the garage door, and then you get wet and can't really keep it warm in there. So anyway, there's a bunch of stuff I could do, but this seemed like the most useful um, since the weather is what it is. So similar to what we had before with the kind of convoluted body scan on here, which isn't great, but I'm working on how to make this that bastard looking growth on here, right? You can, yeah, if you don't have the top and the bottom and all the sides closed in, it tries to make its own surface and it gets this bulbousy stuff on here. So um, I have my other computer chugging along trying to fix on that to delete some of the points to make it so it doesn't make all this bulbous shit. So, but this is what I have to work with right now. So this is what I'm doing. So let me open up the frame assembly. So this is kind of from the concept stages of my cartooning in my notebook. Um, a lot of this stuff is left over that you've seen before. The frame members, stock frame members. These are my connectors. Can't really see them that good, but I'll start hiding some stuff. I got the 10-point cage put in here. I don't have door bars because I don't really want door bars. This is mainly going to be a driver, but I might put something in here where you can bolt in some door bars. So I'll probably do that in case I take it to the track. I've been kicked out of drag strips before. This car ain't gonna run that fast. So anyway, when it does, that won't be a problem. But this is the cage I've come up with. I still have to like do a little bit of measuring and scanning of the 3D surfaces of the fastback body, but I haven't done that yet. But this is reasonably close, I think, if you look at um, where all the bars are, everything is kind of gonna work. I'm gonna close in the vents anyway, so I can chop those vents out of there, and I'll put this forward bar through where the heater box usually lives, like the air intake. That's all gonna be closed off anyway, and the heater's gonna be back here, so that won't be a big deal. All these shock towers are gonna come out for obviously revised front suspension. I still have a little bit of work to do on this exhaust. This isn't going to be exactly where it is, but it's crude, right? It's not going to clear the bell housing as is, but this is a work in progress for certain. But let me go back to the frame assembly. This one takes, if you want to rotate it, it takes a couple seconds to figure it out, which is fine. That's why I have frame assembly where I can, in real time, I can spin this thing around. So I also got to get the front suspension tie-in points and stuff like that, but I have to 3D scan some parts and make the uprights in CAD. So So let's start with the stuff that's easy to delete. So this is the load floor. So this is going to have a hatchback. So all this area will be accessible by opening the hatch up. So you can throw, pretty large stuff in here. These are the stock fender well approximations of them. And then this is um, I'm just going to put a piece of sheet metal in between, just roll it on my bead roller and then weld that in. So it basically widens it. So those are the fender wells. And then, yeah, obviously you can see the load floor here. We can hide that. We'll just start hiding stuff so you can see. So these frame connectors, like this is the original frame in this purple color, and then this green um, goes back through the trunk because the stock frame rails are, let's get rid of these guys, so I don't need those anymore. So the stock frame rails are like way over here, like actually getting into the tire already. So this is another 4 inches of clearance. I may actually move these wheels and tires in a little bit, but this is like the stock location, but I do have some plunge that I can steal, especially since I'm moving this differential forward and up. So those axles will be on a little bit more of an angle than they are in the factory scenario. So doing that for a couple of reasons. Polar moment of inertia for one, and then when this thing squats, I want the angles to be even. So in normal ride height, the axles will be kind of coming uphill a little bit. And I also want to keep this differential out of the diffuser. So I needed to push it up a little bit. So this is not quite done, but this is where the exhaust will break out into this center section of the diffuser, and then there'll be a second kind of, so it'll kind of be a double diffuser. The exhaust will all come out of like a section above, below this first, but above that. So that'll be like a tiered diffuser floor. So this will be closed up here, and then all the exhaust will come out like right where the license plate normally lives. And I'm gonna have to play with these areas. I'll make a little spreadsheet up to figure out what the area ratios are here. This is a starting point, but definitely not done. I have to do some math on it, but this is in general what it's going to look like. I got some jacking rails on here. This is to let the air out of the front in that area. I'll probably get rid of this pinch weld too, so the air will come through and go around there and out. So yeah, this is just like 1x2 for a jacking rail. I did receive one fuel cell already. This one's going to be gasoline. This one's going to be 85. So it seems to be hard to find the alcohol fuel foam stuff. So I just ordered this one. They're the same size externally, but I don't have both of them yet, but that's fine for mock-up stages. This is not the right turbo, but a similar size turbo. I'm going to use a G25 660, which is capable of theoretically 660 horsepower, but in all practical purposes, more like 500, 550 maybe, if you want to run in the efficiency window, which kind of do. So that's approximately where the turbos are going to live. I may move them up or out or on an angle a little bit, but generally they're going to be there. And the G series Garrett turbos have a configuration where you can get a left hand and a right hand, so it'll be symmetrical. So the package will be the same on both sides, just mirrored. See what else we got going on here. Obviously the 10-point cage is pretty generic, I guess. Let's hide these guys. This is essentially a muffler. There's not a lot of room in this for a muffler, so I kind of designed my own. Just open that guy up. Show what's inside of there. – So this is kind of a straight through design, except for not straight, and this will all be perforated. All this giblet-y stuff here will be perforated. And then I may even put like a bypass tube in here that's perforated as well, so it has like a small straight through. Yeah, so that's what the muffler looks like. Obviously, this blue exhaust down tubes are gonna have to, they're gonna have to come out of here and then migrate over here and then into the turbo. So yeah, that's about where we're at right now. I'm shooting for 5 inches of ground clearance because, like I said, this is a street car, and anything lower than that, we're going to be clanging into stuff that we don't want to clang into. So, yeah, I think the next thing, I kind of got everything sorted out where it's sort of going to go, but I need to get a better scan so I can make sure it's going to clear the floor, and then I need to start hanging exhaust or hanging suspension arms and drawing up the uprights and putting some camber caster curves and toe in Ackerman stuff. So there's a lot of work to be done there. So I guess luckily for the rain, I got quite a bit of work done on this. Yeah, as you can see, I've been fiddle futzing around with the exhaust, and this is how you can tell it doesn't work, right? This isn't the greatest scan in the world, but where I have this exhaust right now, it's coming through the floor. I mean, that's not the end of the world. I could put a bump in there. There's nobody's feet going to be back here anyway, so I could totally make this work, but I'm going to try to keep the floor pan as stock as possible. And you can see this muffler's coming through a little bit here too. So I'm using this STL file that I scanned as kind of, that's my template. I can move it back an half an inch, quarter inch, whatever. It's accurate enough for that. And then I got to leave a little clearance. And the way you do that is by just moving this guy in the frame assembly. You keep moving it back a half an inch until you can't see it anymore, right? Because you can't, with these, especially with these bulbous stuff, the bottom's pretty good. But with all this junk here, you can't really tell what's going on that great. So if you hide it in this assembly and you just go back to this assembly, it's way faster to work with that way. Yeah. So these frame connectors are already going to go through the floor. So the floor is going to have to be modified anyway, but not a big deal. A straight line. The other thing that probably should be aware of is this frame rail. Let's pop that open here. So the frame rail, this is made out of 3-inch square tube. I'll just pie cut it and weld it back together. So that's pretty easy. But these guys back here, the rear frame rails, yeah, that's not bendable in my shop. So what I'm going to do is take some 1/8-inch plate and cut it out to this shape. Well, actually what I'm going to do is take some 1/8-inch plate with some flanges here and here, and then bend that to the contour of the trunk, the existing trunk. So now I'll have a piece of, I don't know, 3/4 inch wide, 1/8-inch plate. It's pretty easily bendable into this shape. And then I will use that as a pattern to make this flat plate here, this side. And then I'll have to make 4 of those and 4 of those and weld those together. And then this is basically just a piece of bar stock, 3 by 1/8 inch. And just put it on there, weld it, put it, bend it, weld it until you get all the way back here. So essentially you're making a box section for a frame rail. So, and that's going to be way better than trying to, I I think I got a pretty good idea. This is, the radius of these things that um, Ford designed it to, and they're nice even millimeters, or I'm sorry, they're even inches. They didn't use millimeters in 1968. Um, Even angles. So I'm pretty sure I got this pretty close, but it's not going to be exact. So if I take a um, piece of bar stock, bend it to the inner contour, and use that to make this side plate, then it'll be really close. So that's what I'm gonna do. Anyway, I will uh, I will be posting more of these videos as I get more content done, but um, that's where I'm at right now. Thanks for watching. If you like this content and want more, subscribe, like, and share.